Okay, this lesson is on Lewis dot structures. So we're going to differentiate how to draw Lewis dot structures for ionic compounds and covalent compounds. So when you look at this picture here, think for just a second what these dots represent. So hopefully you said that they represented valence electrons, right? So oxygen has 6 valence electrons because it's in column 16. Carbon has 4 valence electrons because it's in column 14. Okay, so remember we can just count across left to right to determine their valence electrons. If you think about how these dots are arranged, it's important to note that for carbon, right, when I started drawing the 4 dots, I did not want to draw it like this because it's difficult to imagine how other elements can bond to carbon if I draw it like that. Instead, if I draw one at a time as I'm going around, remember, every atom wants 8 electrons, so in their outer shell. So I can see I have kind of one missing on each side. So it's easy to imagine that I might need some type of other element over here where carbon can kind of share those electrons. So we're going to look at ionic first because the way that we draw them is a little bit different. So you have to distinguish, is this ionic or is this covalent before you start to draw? So remember, an ionic bond occurs between a metal and a non-metal. So if you look at the periodic table, you can see we have the little stair step that kind of runs down the right side. Everything to the left of that is metals. Everything to the right of that stair step are non-metals. The elements right on, like sitting on top of the stairs, those are metalloids. We're not going to use those too much because they're funny because they can sometimes have properties of nonmetals and sometimes they can have properties of metals. So that's just shown in their Lewis structures also. So we'll kind of stay away from those and focus just on metals and just on nonmetals. It's important, right? From your simulation, you notice that electrons actually transfer, okay, or move in an ionic bond. So one element is going to take an electron and the other element is going to give the electron away. So let's look at NaCl. The first thing we're going to do is just write out our elements, okay, and then we want to draw their valence electrons. So sodium is in column 1, so it has 1. Chlorine is in column 17, so it has 7. Okay, so I see I only have one spot that's missing on the chlorine. Now, what's going to happen, right? Remember, chlorine has a much higher electronegativity than sodium, right? It's on the right side of the table, whereas sodium's on the left side. So that means chlorine is actually going to attract the electron from sodium, which makes sense because chlorine only needs 1 electron to have a full outer shell. And if sodium loses an electron, then it will have a full second shell. So its 2s and 2p sublevels will be full. So that gives it that full outer shell. So the way that we show that is we actually just draw an arrow showing how the electron is going to move. And then remember, when we have ionic bonds, right, we are forming ions. So we are going to give our elements a charge. So if chlorine gains 1 electron, its charge is going to be 1 minus. If sodium loses 1 electron, its charge is going to be 1 plus. Okay? Let's look at calcium chloride. So again, I'm just going to draw my elements. One thing, whenever you have, like, notice here, this means I have 2 chlorines. Okay, I'm going to put those on the outside, and then I'll put calcium in the middle. Right? So Remember, I'm just going to draw my electrons. Chlorine, again, we know has 7. Calcium was in column 2, so it has 2. Chlorine has a higher electronegativity. It's going to attract those electrons, so we're just going to draw these electrons moving. Okay, so one will go to one chlorine, one will go to the other. Remember, as chlorine gains an electron, its charge is a 1-. And then notice calcium, it actually loses 2 electrons. So when it loses 2 electrons, its charge becomes 2+. Okay, and if you notice, my charges always balance out to be 0 or neutral. So 1-, 1+, that's 0. 2 1-, and then a 2+, that's 0. Okay. These other two are very similar. You'll draw them just the same way. When we look at covalent, remember these are between nonmetals. So if I'm looking at a compound, I know that I'm going to draw a covalent Lewis dot because it's all nonmetals. It's going to look different because electrons are shared in a covalent bond. Okay, so when we're drawing our structures, okay, we want to note if we actually have kind of instead of drawing so many dots, we can draw lines to show that the electrons are being shared. So if it's one pair of electron, it's just one line. If they're sharing 2 pairs, it's 2 lines. If they're sharing 3 pairs, it's 3 lines. And then if it's just a lone pair of electrons, right, we'll just still use the dots. So each line is going to equal 2 electrons. Okay, so when I'm counting, each line will count as 2. So let's look at a few examples. I won't do all of these, but I will post some sort of key that you can kind of use as you're practicing on your own to check your answers. So these are all covalent, right? Hydrogen and sulfur are nonmetals, so I'm going to draw them a little bit differently than I drew them for ionic. The first thing that I need to do is count my number of valence electrons because it's important that I'm not drawing too many. Okay, so hydrogen, right? Each hydrogen has 1, but there's 2 hydrogens. So that means I'm going to have a total of 2. And then sulfur is in column 16, so it has 6. So that means my total number of valence electrons is 8. When I draw my structure, there's a general rule that the lowest electronegative goes in the middle. When you have hydrogen and sulfur, it's a little bit different because hydrogen can't go in the middle. Because if you think about hydrogen, it already has 1 electron, but it is in the 1s subshell. So S can only hold 2 electrons total. So that means hydrogen's only missing 1. It can't have any more than 1 element bonded to it, so we can't put it in the center. So I know that sulfur's got to go in the middle, so I'm going to go ahead and draw my 2 lines connecting sulfur. Now, I'm just going to count. So remember, my line is 2 electrons. So now I have 1, 2. 2 pairs, right? So that's 4 total electrons on my drawing right now. Remember, I need 8, okay? I can't draw any more lines because I've got everything connected. So I'm going to start drawing dots. So hydrogen, like we said, that's all it can have. It can only be bonded to one thing. It can't have any lone electrons. So my other 4 electrons, I'm just going to put around sulfur. Okay, and as a general rule, we don't put electrons on the top and on the bottom of something in the middle. They always just go around the top. So it's going to influence the shape of the molecule that we'll talk about later. So just kind of go ahead and start getting in that habit. Okay, let's look at the next one. Carbon has 4 valence electrons. Oxygen has 6, but there's 2 of them. Okay, so that means I have a total of 16. So this one has a little bit more. Remember, least electronegative goes in the center. I can go ahead and put my oxygens around the edge. Okay, so I have 2 4 electrons now, and I need 16. We're going to start putting our electrons around the outside atoms first. So the only reason I started in the center here was because I had hydrogen on the outside, and I can't put anything on hydrogen. Now that I don't have any hydrogens, I'm going to start putting my electrons on the outside, and you'll see why in just a minute. It makes it a lot easier. So remember, I need 16. So 2, 4, 6, 8, 10, 12, 14, 16. All right, I have my 16 valence electrons, so I cannot draw any more dots, all right? But remember, every atom wants 8. So I have to make sure that each atom has 8 electrons surrounding it, okay? It can be sharing, but it has to be 8. So let's count here. So oxygen has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8, but my carbon only has 2, 4. So what can I do to make this, allow my carbon to have extras? Okay, so think about it. Covalent is going to share. So this carbon is actually going to share some electrons with my oxygens. So what I'm going to do is I'm going to take these two, okay, and I'm going to move them down here so that they're in a line, okay? Now that I've done that, I'm going to erase the pair that was there, right? Because I moved them. I can't draw extra, but I can move because now I still have 16, okay? This oxygen still has 8, okay? 2, 4, so 2 here, 4, and then 6, 8 in the lines, okay? But my carbon, still it doesn't have 8. So I'm going to come over here and do the same thing. I'm going to move those into a line, and then I'll erase those. So now everybody has 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and I still have 16 total, 2, 4, 6, 8, 10, 12, 14, 16. Okay, let's look at some more. So here is CH4, 4. Hydrogen has 1, but there's 4 total. So that means I have 8 valence electrons. Remember, my hydrogen can't go in the middle. So I'm going to put carbon in the middle. And then I always start by just connecting everything with lines. Now I can just count, see how many I need to add. Okay, so this is 2, 4, 6, 8. I have 8. That's what I need, right? Now I just have to double check to make sure everything has 8. So do all have 8? Okay, so my carbon has 8, 2, 4, 6, 8. Remember, hydrogen only needs 2 because it only has the 1s subshell. Okay, so hydrogen's kind of the special one that only needs 2, and it does. All right. Let's look right here. I think I have I2 on this slideshow twice. So iodine is in the 17th. So that means 7, but there's 2 of them, so that's 14. Okay, there's 2 iodines. So I'm just going to draw them connected to each other with one line, right? So this is 2 electrons. So now I'm just going to start adding my dots until I get to 14. So there's 2 is in a line, 4, 6, 8, 10, 12, 14. Do I have 14? Yes. Double check that everybody has 8. 2, 4, 6, 8. Yep, okay. 2, 4, 6, 8. Yes, okay. Everybody has 8, so that means we're good to go. Okay, let's look at O2. So this is 6. There's 2 of them, so that makes 12. Okay, I know I'm just going to put them next to each other, lined up. That line has 2 electrons. So now I'm going to go through and add until I get to 12. So 2, 4, 6, 8. Sorry, I forgot to count my line. My line is 2, 4, 6, 8, 10, and 12. So I've got my 12. I can't add anymore, but this oxygen right here only has 6 electrons, right? And that's not right. I want it to have 8. So how can it get 8? It's got to share, right? So this oxygen is going to have to share its electrons right here. So we're going to put a line there. We're going to erase the ones we moved. Now we still have 12, 2, 4, 6, 8, 10, 12, and everybody has 8. This is called a double bond right here. Okay, when you have 2 lines, a double bond. Let's see what other one I want to do. Let's do this one, NF3. So nitrogen has 5, fluorine has 7, but there's 3 of them. So that means 21, so 26 electrons. Nitrogen's going to go in the middle, and then I'm just going to put the fluorines around the nitrogen. Okay, that means now my lines mean I have 6 valence electrons, right, that are being shared. I'm going to start adding until I get to 26. I'm going to start adding on the outside. So I'm starting with 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that's 24. Everything on the outside has 8, but I have 2 more that I need to add. So where do you think I need to add them? On the nitrogen. Okay, because so now everybody has 8. I didn't have to share any because I could still add 2 more. Okay, so now I want to double check to make sure I'm done. I need to make sure I have 26 drawn, and I need to make sure everybody has 8. Okay, and I think those are both good. All right, last thing we need to look at is something called a polyatomic ion. So these are very similar to what we've been doing. Nothing is changing except for we are going to, sorry, my screen flipped. We're going to pay attention to the charge of the ion. So all this is it's kind of like where you have a bond, like these elements are bonded together. So we have more than one element, more than one atom, but they function like one thing. And so as a whole, this whole thing has gained 3 electrons so that it has a 3- charge. Okay, so we're going to, when we count our valence electrons, we're going to add 3 because it has gained 3 for the 3-. Okay, so phosphorus has 5 valence electrons. Oxygen has 6, but there's 4 of them. So that's 5 plus 24. And then don't forget, I have to add 3 more because of my 3- charge. Okay, so I end up with 32 valence electrons. So I'm just going to start drawing. So remember, I'm going to put phosphorus in the center. There's only one of them, and it's the least electronegative. My oxygens go around the outside. I've already drawn my lines connecting everything together. So that's 8 electrons in those lines, right? Because everything is a pair, 2, 4, 6, 8. So now I can just start adding dots. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. See, and now it's a beautiful structure. Everything matches up right. Okay, I have the perfect number of electrons that I need, right? That's why it took 3 electrons from something else, because it needed that to make this perfect little structure. So because this is a polyatomic ion, I have to do something to designate it's an ion, because right now it doesn't look like that. So I'm going to draw brackets around it, and then I'm just going to write the charge. That just lets me know, oh, this is a charge, this is an ion, and it actually took 3 electrons from something else. Okay, let's look at the next one, because this has a plus. So hydrogen, it's 1 times 3. Oxygen is 6, and then don't forget we have a plus 1. So 3 plus 6, and then remember, if I have a positive charge, what does that mean? It means I lost an electron, so I have to take an electron away. Okay, so that means it only has 8 valence electrons. So when I draw it, oxygen is going to go in the middle. Here's all my 3 hydrogens that I've connected with a line. Remember, I can't add anything else to the hydrogens. I can only add to the oxygen. So I have 2, 4, 6. There's the 2 more to make 8. And then remember, because it's an ion, I have to put the brackets and then write the charge. Okay, because otherwise I wouldn't know. The only way that this was able to make this nice, pretty structure with the perfect number of electrons is because it had to give away 1. Okay, so it has a +1 charge. All right, see if you can do SO4, and I think this is actually supposed to be a 2 minus, so like a -2 charge, not a -1. So let me like cross that out so that way you can try to fix that. Like I said, do your best. Try some of these kind of on your own, and then I'll post a key of some sort with some more practice and stuff, and you can kind of check how you did.